Okay, this is IVLT, where we're looking at invertible linear transformations, C20. And this is sort of a review of all three sections. Is T injective, surjective, or invertible? And here's T. It basically takes P2 and it maps it onto a 2x2 matrix, and here's the mechanism by which it does it. So the first thing we look for, and again, this would be the surjective part, but we'll get to that in a second, is it takes the 3-dimension and it moves it to 4, and anytime you increase in dimension, then surjective is out, so we can strike that off the list. But first, let's look at injective. Injective is a little bit harder. For injective, we need the kernel, that is the null space of the V, the output, to be 0. So let's test that. So that means setting up this system, A plus 2B minus 2C equals 0, 2A plus 2B equals 0, negative A plus B minus 4C equals 0, and 3A plus 2B plus 2C equals 0. And that ends up producing a matrix of 1, 2, negative 2, negative 1, 1, negative 4, 2, 2, 0, and 3, 2, 2. And if we throw this guy through the RF process in order to find basically the null set of this matrix, this is what we get. We get 1, 0, 2. We get 0, 1, negative 2. We get 2 rows of zeros. And that's bad news, because we needed this to produce all zeros, and it won't. It'll produce 2 zeros and 1 free. So in essence, what it means is we're going to get a system here that produces an infinite number of solutions, and we needed there to be 1. We needed this to be a consistent set with 1 solution in order for this to be injective. And so because the null space, basically the kernel of T, is non-zero, all we need to do is just say that. And there's a theorem called KLT, and that says, therefore, T is not injective. So that takes care of that. How about surjective? Well, we already talked about it, because the dimension of TU, basically U, is greater than the dimension of TV. Excuse me, the opposite. Then, according to SLTD, T is not surjective. Because remember, surjective requires that it either maintains the same dimension or it moves down, okay? But this one moves up. Okay, so that takes care of part C. Invertible by theorem ILTIS. So ILTIS. And that basically says in order to be invertible, it has to be surjective and injective. And this one's neither. So neither. Therefore, T is not invertible. Which means there would be no way to take the output and move it back to the input. There is no linear transformation that would undo this transformation, and it's because it's not both injective and surjective. And that's it.